All right, welcome, ladies and gentlemen, back for another live stream. My name is Brian McLogan, and we are going on week 29 or week 28. I'm sorry, open Q&A, where I am here to answer your questions and get you guys ready and prepared for the upcoming school year. I see that Ja already gave me a lovely super chat. Thank you so much. I really do appreciate that, and I will be getting to your guys' questions here. Coming up, you can see we have some good questions. Actually, a lot of questions, because if you were joining me last week, where Jacques gave me another super chat, thank you so much. I love you. That's awesome. I really do appreciate it. And I do apologize, guys, for wearing white. I did not mean to do that. It was just something that I got ready and prepared for my live stream today. But so yeah, we are going to go ahead and go through some questions as far as talking about end behavior. Talk about degrees. Let's see. We got graphing without a square root function. Rationalizing the denominator. Let's see. Graphing a line through a point with a certain slope. I think we're talking about Trigon vectors. SAT exam. Oops. Let's see. Solving some inequalities. Doing a derivative. Finding the equation. Those points. So yeah, a lot of questions that are coming up. Thank you so much for you guys that have submitted those questions. It really does help me get prepared for these live streams. If this is your first live stream, basically what I do is go every Sunday night. I go live here at this time and I answer your questions. So people go ahead and pre-submit the questions using the Google form, which, as long as I did that correctly, is in my post down below. Yes, it is. So there's a Google form that you can go ahead and click on. That I go ahead and accept your answers, where you can kind of write in your question, and then I try to do my best to get to as many questions as I possibly can for each and every Sunday night. But also, I like to always add on these live streams is getting into kind of letting you guys know some of my thoughts, because I always kind of think of, July here as like the halftime. So if you were on my live stream last week, you guys noticed that I was in Michigan. I was just doing a little vacation. I literally got just to unplug from really the world and not really worry about everything that was going on or think about teaching or really doing anything. I did go live again on Sunday. That was my way to kind of connect back with you guys. And in that live stream, I kind of explained why I was doing that while I was on vacation. Because it would have been a lot easier just to say, I'm on vacation, let's take a week off. But I was like, nope, I'm determined to continue going each and every week live with you guys. And what's it? So yeah, so it was really good just to kind of take a step back, and but now we are in the second half, where I really think of once after the July begins, it is now getting prepped and prepared for our upcoming school year. So that's really where my brain and mind is on right now, is getting ready for the school year. And, there's a lot of things that I am doing online to help my students be prepared, because I don't know how things are going to be. At the beginning before I went on vacation, we were supposed to be doing a kind of hybrid model, a couple days in the classroom and then a couple of days distance learning. And then while on vacation, we kind of got the directive that we will be going in the classroom 5 days a week. And now it's kind of turned into, I wouldn't really say so much as political, but yeah, maybe political, that, people are really kind of concerned about going back into the classroom. Obviously, where I live in Florida, the cases of coronavirus are obviously increasing. So, I just wanted to kind of think about my, thought process, because obviously I am just one person and really my opinion doesn't really matter as much, or do I have all the information to really make a, to provide any really advice. But, just really from the way that I see things, the way that the year ended off last year, from my perspective, it was rather easy for me because I do a lot of teaching online. But I know a lot of teachers struggled with teaching online. I know a lot of students struggled learning online. They weren't used to having to learn something online. And also a lot of parents, definitely really struggled with having their kids at home, getting work and all that kind of stuff. So, I really think that it is really important to try to kind of overcome a lot of what we've been going through these last couple months, to really try to implement in a school, going back to school as much as possible. And I obviously know that that's going to all be impacted on, the health and safety of the teachers, the students, and, everybody that's really included into the school system, obviously administrators and janitors and personnel and everything like that. But I really think that the goal and the main push should be, how are we going to do this, and really try to focus on getting it done rather than trying to avoid it. And I think the biggest thing that I am kind of most excited about is to have that happen. There's going to be some fundamental changes in education, which needed to be happening anyways. So, the way that we teach math, the way that we teach other classes, not so much doing this in person or online, but, one of the things that I am creating for my classes is, I'm streamlining a lot of stuff. So, for those of you that are going into pre-calculus, I have my training tomorrow on getting prepared for pre-calculus. Well, one of the things that I've been doing for my pre-calculus classes is I've really been taking all the content that I've already created so far, and I have just been compacting it further and further down. Like every year, it seems like I just start teaching less and less because I really get zeroed in on exactly what I want my students to know. And I provide additional resources, if they need further information or further practice. But I've really tried to take what I want my students to know and just only focus on that, because throughout teaching a course over multiple times and years, you really get a better understanding what is it exactly the students need to know, as well as what you want to know. And I think a lot of students, what I've seen a lot of frustration that students have come from, that come to me for help or anything else, is they're just being thrown so much information for them to try to learn. And, in the reality of where we are in education and with technology, a lot of the stuff students don't really need to know, or we can use technology to our advantage for this. And so yeah, I think, without getting into specifics of that, I think is going to be some interesting conversations that we're going to have as far as what is it we really want our students to know? Why do we want them to go through high school to middle school, through college? What is it we want them to take away from that? And how is that going to help them prepare for whatever degrees they're going for or the real world? And I think that's something that we've always said, of course, as like a blanket kind of statement, but now I think it's actually really, really important that we need to really follow through. It's not something we can just say it and then just do the same old, which has really been occurring, in my opinion, for the last number of years. So I think now we really need to really look back, reflect as educators, and as a society, really, and really determine what it is we want to be the outcome for our education, and really use this as an opportunity to make those changes. Because going back to the old system is just not feasible. It's just not going to happen. And I don't see that as a political point from one way or the other. It's just the reality. It's not so much even of, what's going on. It's just, we needed to change everything anyways. I mean, so anyways, that was my little rant that I wanted to go through with you guys. I don't know why I'm getting lost over here. All right. But yeah, so anyways, before I get into the questions, that's what I was looking for. I just wanted to give you guys a little bit of my opinion. I do have a couple things coming up here in the next couple weeks that I'll continue kind of talking about that, especially as things change. But otherwise, I am planning on going back into the classroom in August. And I am also planning on, again, just a reminder, doing my live training. I think also that's what I wanted to check, is my PC Foundations. It is. So if you guys are interested if you are taking pre-calculus and you're looking for your summer kind of packet or work or to prepare for it, sorry guys, I don't have it for every single class, but feel free to go ahead and join my PC Foundations training, which I am doing every Monday in addition to this live stream. And there you guys have a workbook, which is free. You guys can download it. Even if you're not taking pre-calculus, if you're taking calculus, algebra 2, college algebra, trigonometry, anything related to a lot of those core algebraic concepts, even like SAT, SAT, ACT prep, I bet a lot of these problems would just be helpful for you to kind of review and go through. Again, guys, it is free. Just go to the free PC Foundations, and you guys can go ahead and take a look at it. And then I'll be doing trainings here for the next 4 weeks before we get into that. And otherwise, besides that, I would like to also give a nice little shout out to all of you guys that are supporting my channel. You guys notice I have been creating some new videos, just some kind of fun little things I've been doing, and that is definitely due to all of you guys that are supporting me on the YouTube membership. I definitely look into continuing that and bringing some more value throughout the school year, and just definitely to what I'm doing on my channel and what's coming up from there. So if you guys are interested in that or just want to kind of see what further perks I provide on that, go ahead and check it out. But otherwise, guys, I would go live every Sunday night. I answer your questions, and I am going to continue to be making some videos if I am in the classroom or not in the classroom. I will be making some more free content for all of you because I do greatly appreciate you guys checking in with me, all of your support. I wanted to pop out my chat. I don't know why I did not, so therefore I'm going to do that now. That way I can say hi to you guys and not look so weird from that. Okay, all right. And I saw a lot of you guys saying hi, and I do apologize. I wanted to get into that. We'll get you at 500,000, Mr. McGowan. Well, thank you very much, Neso. Abduram, how are you? Peeves, thank you very much. Feder, Mark, your opinion does not matter. Mr. McLaughlin is never wrong. Thank you, Mark. Always great. Appreciate to have you on. Victor, McLaughlin 2020. Well, we'll see. And thank you so much, guys, for all of you joining in. I love it. Let's go ahead and get onto some math. We'll see how long these math, typically, guys, you know, since like COVID has really happened, I've only really done about like 5 math questions. I think when I first started doing these live streams, it kind of got crazy. I was doing like 10 of them. And this is the first one that you guys really kind of threw in some questions. So this is cool. I'm kind of excited about this. I'm not going to spend as much time explaining everything just because I need to get through all of this content. But hopefully at the end, guys, if you do have any other questions, I will jump back into the chat. But for the next maybe 15, 20 minutes, I am just basically going to kind of focus in on these math problems. But I did want to let you guys know, if you do have a question, please post it on the chat, because obviously there's a lot of great people that are willing to help you out and understand your situation or understand the question that you're asking, and they'll either help you out in there, and then also I still use Discord for you guys to provide different questions based on the course that you are taking. So if you go to my Discord, I have consistently been making some upgrades to the server. So therefore, more and more of you keep on joining in, asking questions, communicating with each other, and getting help. That is also a great way, guys, because obviously I am a one-person show. I am not going to get to everybody's questions. So without further ado, who's the oldest one though? Well, that's very weird. Okay, you have Discord? I do, and I'll check the link. I'm almost positive the link is again everything's in my description, guys. So if you guys go ahead and take a look at my description, follow my community. Maybe I didn't put the Discord. I'm sorry about that. Well, excuse me. If you go actually to the Discord, if you actually go to the Discord form, then what you will see is if you go to the Google form to ask a question, there's the Discord link right there. So you can go ahead and join from there. So that is at least an option. And I do apologize. I'll make sure our post stream that I put that link back in if you are on Discord and like to go from there. So, all right, ladies and gentlemen, let's go ahead and get onto that. I was never a Discord fan, but I developed bots and use it for math. Well, that's awesome. Yeah, I think just Discord has kind of worked better. I've tried using Facebook and other things, and I just kind of found like Discord. I just kind of like how it's not tied to any kind of other social media. It's just really there where we can focus on different things. And I'm in Discord for a couple other groups that I'm a part of, so that's why I thought it'd be beneficial. So, all right. First question, guys, we are going to get started with is from Aiden, and it says, how do you determine the end behavior of a rational function? Now, Aiden brought in this question, or at least what they did. And if you just simplify this, I mean, you're just going to get the answer 2. So basically, you just have a line that is 2. So even though it's going to have some holes in there, as far as the end behavior, we're looking at what is this graph doing as the x values get infinitely larger as well as infinitely smaller. So if you just have a horizontal line, even though it has holes, that doesn't really matter. We're looking at what's happening as x is getting infinitely large and infinitely small. So this end behavior is going to be approaching 2 from the left as well as from the right. But I think if Ada maybe made a mistake typing in the question or anything like that, basically what I would recommend is when you're looking at a rational function, we're basically looking at the growth, okay? So what I mean by that is what is growing faster? And again, this kind of gets into a little bit more calculus, but we can just kind of explain things because you basically have 3 options here. Okay, so what if the growth here in the denominator, okay, is larger than the growth in the numerator? Like for instance, let's just say we had a linear function divided by a quadratic function. Well, it doesn't matter what your linear function is. Anything that you have squared is going to grow faster than in the numerator, right? Even this was like, x squared and this was 100x, 100x. Well, eventually though, as x gets infinitely larger, the denominator is going to grow larger than the numerator. So what that's going to do is that's going to produce a horizontal asymptote at 0. So we can say the end behavior as we go from the left or from the right is going to approach y is equal to 0. Now, what about if the growth was the same, like x over x or something like that, or it could be x squared over x squared or e to the x over e to the x. It doesn't really matter what the function is, but if they have the exact same growth, right, even if it was e to the x plus 1 and e to the x, you still have that power function of e to the x, which is going to be the same. So therefore, as they get infinitely large here, they're going to approach what we call our horizontal asymptote. Now, in this case, I'm dealing with a rational function, nothing crazy, but basically you just want to find that horizontal asymptote, and that is going to be your end behavior from the left and from the right. And again, guys, I'm just doing a very short summary here. So don't think of these as graphs or equal or anything like that. And then the last type of growth, guys, is going to be, well, what about if the numerator grows faster than the denominator? Well, then in that case, again, unless there's a hole, right? But then in that case, you're going to have some what we call a horizontal or a slant or an oblique asymptote. And therefore, again, you can look at that asymptote as far as where is it growing. You can look at it as approaching infinity or negative infinity and so on and so forth. So just going off of this one question, there's just a quick little summary. Obviously in calculus, we get in much more in depth, and in pre-calculus, I talk about this a lot once we get into limits. We go over this at limits at infinity, and we kind of cover this in a lot more details. But hopefully, at least for this, for the live stream, this makes a little sense and gives you a little bit of that foundation. All right. Aaron says, why is 1 degree equal to 60 minutes? So very good question. And that kind of brings in the idea of really a degree. Like, why do we have degrees? Why do we have minutes? Why do we have seconds, right? So it really just kind of comes into our measurement, and without going into the history of our measurement system, because it is something that I've studied, but it's not something that I have very well that I would accurately probably speak about. But obviously, I will just kind of summarize just to a basic understanding and idea. So here's a circle. And if we think about like when we're trying to identify like what would be the measurement, how can we measure this rotation of a circle, right? And, think about ancient civilizations, looking at what was it? They're looking into ancient civilizations. So they were looking at, how far the earth rotated around the sun and how long that took and the stars and all that kind of stuff. Well, if we need to have a measurement system, right? We need to say, how can we like break this up? And I think they counted in, I can't remember, I wish I would remember this book, but basically they figured out that the number of days in the year was roughly around like 365 or, 364 or something like that. But anyways, really to kind of break this up, 360 5 or 7 or whatever the number they figured out, is just not a very good number. It's not very divisible. But if you just kind of break this up into 360 degrees, right? Well, then that kind of works. I mean, that kind of makes it nice as far as this rotation of 360, because 360 is a very divisible number. And then if you kind of have like your, all right, so then we're going to say, all right, one little slice then is 1 degree. Well, how can we break that up, right? And again, it just kind of comes into, what is kind of a preferred method? We think about like our metric system, like, we have a meter, we could break it up into bases of 10, right? Well, in degrees, it's really just kind of comes into, rather than using units of 10, like the metric system, we can go ahead and use just 60. And again, because we can break 60 minutes into 1 degree and then 60 seconds into 1 minute, just like time. And again, as far as the reasoning of why, it's just I don't really actually have a good explanation of the why. And I know there's a lot of conflicting reads, and maybe there will be something else that explains it better than what I'm trying to do. But as far as I have concern, for what I've at least read up and understood myself, it's just been a way to break up those units of measures that made sense and that worked. That it was just easy divisible. Like if you have this little slice, like, of course we could break up this into 10 different parts, right? We could break it up into 12 different parts. We have a circle. We could do that we could break that circle into 367 parts. Like, it doesn't really matter how you want to break it up. 360 though, is very close to like the number of days in the year, which kind of made sense way back in the day. And then also it's 360 is very easily divisible. So we can break it up in many different ways, which as far as doing mathematics, is going to be very useful, compared to like 367. So hopefully guys that kind of made a little sense, and I wasn't totally far off on my, history or explanation. But yeah, that is why when we do trigonometry, I usually talk about this a little bit more. And that's why I have done some research in the past when I wanted to explain it, because that's why we really truly like the idea of radian measurement over degree measurement, because really degree measurement is, kind of just exactly the same, like made up, it's used. We use it. We like it because it's nice and easy. It's simplified, but it's not a very good description of like, what is a degree? What is a minute? It's just kind of a useful measurement system that has been adopted. But as far as like an understanding of that measurement system, it doesn't really give you that concrete of idea of what you're dealing with, like a radian. All right. Good job, Ben. Just a little thing. Wish you all the best. All right. Here, Raj. Sorry, guys. I can't. Prabraj. I'll try to do my best with your name. Sorry about that. I'll just say I'm horrible. Anybody that has me as a student or anybody that has me as a teacher, I just bomb their names, and it just seems like it gets worse and worse. I'm supposed to get better and better as a teacher, and I think I just get worse and worse. But anyways, so let's go into this. He gave me this question as far as graph f of x equals -3, 2x plus 5, square roots, of 2x plus 5 minus 4. And without a calculator, I'm using a table of values. And then I thought to myself, that just does not sound like a lot of fun. Now, when I teach this to my students, we would do something like this without a calculator. But I would just have them sketch it. So what I'm going to do is I'm going to show what I do in my classroom. And then I will show a little bit of a table of values just to kind of give you an idea, okay? Because obviously a calculator, guys, is going to be the fastest and easiest way to do this, all right? So let's just go method number 1, which is my method, which is a very basic and quick way to get an idea of what's going on here. So my method would be to take this function and identify the transformations. So I'm going to factor out at 2. So 5/2. Okay, minus 4. All right, now without writing out the transformations, I'm just going to kind of go through them. I am going to be reflecting the, reflecting the x-axis. I'm going to have a vertical stretch of 3. The 2 is going to be, a horizontal compression by a factor of 2. I'm going to shift the graph horizontally 5/2 to the left, and I'm going to shift the graph 4 units down. So that's So that's the first thing you want to do, is make sure you have it in your transformation form. The next thing I'm going to do is I'm going to look at, all right, well here, when I'm graphing this, by the way, I'm just sketching the graph, okay? So if I just wanted to, here is the parent graph, right? This is not f of x. This is just the parent graph. So what I'm going to do is I'm going to take this graph, I'm going to reflect it. So if I reflect it about the y-axis, or x-axis, I'm sorry, it's now going to go like this. Vertical stretch of 3 is going to be now going down lower and over. Horizontal compression is kind of the same thing as a vertical stretch, right? It's probably even going to be a little bit more going like this. The graph is now going to be shifted 5/2 to the left. So that's roughly like, what, 2.5? So let's do 2. So it's 2.5 and then down 4 units. So 1, 2, 3, 4. So we're going to go left 2, down 4. It's going down and it's vertically stretched. So it's going to look something like that. Okay. And again, in my class, for what we'd be teaching, that'd be perfectly fine. Now, this student wanted me to do a table of values. Now, table of values gets a little tricky because if you're going to do table of values, you can only really take the square root without a calculator, or at least, to have your integers, with these kind of 4 numbers. So you're kind of limited on what numbers you can really choose to go ahead and take the square root of. So here's basically what we want to do is basically figure out, like, how can I get 4? How can I take 1? How can I get 9? So these are going to be the values that I'm going to choose that I want to be as my input. So it's kind of weird, but what I would do, and I've actually never done this before, so I'm not even sure if this is a great way to teach this, just because, once we got it, let's say I wanted to get 1 under my radical. So these aren't going to be your table of values, but what you would do, 2, so x equals -2. So I can figure out when x equals -2, that will give me 1, and I can take the square root of 1, okay? And then let's just do maybe one more. How about I want to get 4? So if I had 2x plus 5 equals 4, okay? So I'd subtract a 5. So 2x equals -1, divided by 2, divided by 2, x equals -1/2. Okay, so by creating my table of values, you have your x and your y, right? Because usually the problem with when students are choosing their table of values, like, what numbers do I pick, right? And you don't want to pick any number, because let's say you pick 1. So 2 times 1 is 2. 2 plus 5 is 7. I don't know the square root of 7 besides 2.6457513, right? But besides that, I don't know the square root of 7, without a calculator. So then I'm kind of stuck. Like, how am I going to graph that? So I want this radicand to be 1, 4, 9, 16. I want it to be one of those numbers. So that's why I kind of did this little math here. And again, you could keep on doing this. You could say 2x plus 5 equals 9 and 16. And, it just depends on how many points. For me as a teacher, I just want 1 point and the students to know the transformations. But anyways, let's say, so my point was -2 and -1/2. Okay. All right, so let's see what happens here. So when I plug in -2, so that's going to give me again, that gives me 1, right? -2 times 2 is -4. -4 plus 5 is going to be 1. Square root of 1 is 1. 1 times -3 is -3. -3 minus 4 is a -7. Okay, and that kind of makes sense here, right? -2 is all the way down there, -7. Oh, I guess we could have done 0 too, right? 0 would have been a good one when we want that to get 7, but yeah, we could have done the square root of 0 too. That would have been a good first point. And then let's do -1/2. -1/2 times 2 is -1. -1 plus 5 is 4. Square root of 4 is 2. 2 times -3 is -6. -6 minus 4 is a -10. Let's do 0. Oh, sorry. Well, if I wanted 2x, let's do this again. So if I wanted, let's say 2x plus 5 is equal to 0, 2x equals -5, divided by 2, divided by 2, x equals -5/2. All right, let's do this last one. So if I plugged in -5/2, the 2's would divide out. That'd be -5 plus 5 is 0. Square root of 0 is 0. 0 times -3 is 0. 0 minus 4 is -4. So now you have these coordinate points, right? And basically now you can just kind of plot. Let's say you have, -5/2, right? -4, which we already had. You have -2, -7. And then you have, let's see, -1/2, and that's going to be -10, right? So I think my graph is pretty good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, we'll just kind of make it work from there. But you can see how I kind of got those 3 points using the table of values. It's a little bit tricky, and especially for students that are struggling with graphing, I wouldn't really recommend that. I would, I think knowing transformations is going to be more useful. But again, it just depends on what your use is for the technology and so on and so forth. All right. I'm not sure. Is in his channel. Yeah, I'll go and get it. All right, so let's go and take a look at the next question, which was basically like, how does rationalizing the denominator work? Because the student was asking that I think in their answer or something like that, they had like 6 plus the square root of 7, but they didn't understand how that like got rid of the radical, because they were thinking like that's going to, when you multiply by 6 plus square root of 7, that's going to make a quadratic in the denominator. But again, we need to remember like what is completing the square. Like if or rationalizing the denominator, if I have a minus b times a plus b, again, when you multiply this out, you get a squared plus ab minus b squared. So really just get a squared minus b squared, right? So the middle terms cancel out. So when you multiply, these are what we call our conjugates. When you multiply these conjugates, your middle terms basically divide out. So really all we're doing is squaring. We're multiplying the first 2 terms and multiplying the last 2 terms, because the middle terms are going to, add to 0 basically. So when I do this, so I have 4 times 6 plus the square root of 7. So let's go ahead and square or multiply this denominator. So if I just say, forget about the middle terms, let's just multiply 6 times 6, well, that's 36, and negative square root of 7 times square root of 7. Well, negative square root of 7 times square root of 7 is going to be a negative square root of 49. And now you can say that, that simplifies to 7 here, right? So we can do 24 plus 4 square root of 7. And actually, let's just simplify that to 7. Just keep ourselves some time here. And that's going to be over 29. And now you can see I got rid of my radical in the denominator. So that's how the multiplying by the conjugate helps us get rid of the radical in the denominator. Alice, I am still answering questions, but right now I am just working through the questions that I have, which is about 9 of them, and then we'll kind of see how long that takes me, and then I'll maybe address whatever questions I have. But again, guys, if you are just joining me late, please feel free to go ahead and go to the Google form in the description to go ahead and post your questions for next week, or go onto Discord, which is in that Google form. I have the Discord link there as well. And actually, that's what I'll just do. You know what? I'm just going to, sorry, everybody, some people were asking about the questions. And I was like, you know what? I am just going to copy that in there. So again, if you guys want to go to Discord, you guys can go to the Discord. Ooh, that's not good. Valid dynamic link. Okay. That's not good. Oh. Huh. Yeah. All right, cool. So I am going to, it has like a period on the back. All right, so for those of you that are interested in the Discord, there is the link for you guys to go ahead and join. And I will go ahead and add in Discord link there as well. Okay, because yeah, guys, I'm going to try to get to as many questions as I possibly can, but obviously I'm not going to be able to get to everybody's question on the live stream, or at least every week. So that's why I kind of provide you guys with the Discord for you guys to check in from there. All right. But again, I will be taking some questions after I'm done with the live stream for those of you that are still hanging around with me, and we'll check back in from there. So the next one is graph the line when the slope is m equals 2 that goes to the point 4, 4. So there are a couple different ways you can look at this. I think the easiest way to understand this is using the point slope form, which is y1 minus, or sorry, let's do y minus y1 equals m times x minus x1. Okay, there's a couple different ways that we've used the point slope form, but I think whenever you have a point, you can represent this as x1 and y1, right? Because a point represents a set of infinite many points. And then we have our slope. So if we just plug in this point here as an x and a y, and 2, remember what the equation of the line is representing all x's and all y's, right? That relationship based on the slope. So just using this, I'm just going to plug in 4 equals 2 times x minus 4. All right, and there is an equation of a line. Some people are more familiar with slope-intercept form, so you can go and do that. Just go ahead and distribute, and then add the 4 to the other side. So you get y equals, let's say, 2x minus 8 plus 4. And then y equals 2x minus 4 would be your equation in slope-intercept form, okay? So, and again, that is an equation that represents all the relationship between all x and y's. We'll create that line. But again, in this problem, we were only given 1, so that's why we want to use that point slope form. JBoss380 gave us a question. He was going into trig and asking me what he should know basically for trig and vectors. And I don't really like these questions because it's kind of difficult for me to really understand what the student needs or what is like a good explanation. But I'm just going to try to do my best to kind of describe at least vectors with a little bit of trig. So I don't really know what JBoss knows in regards to trig or with vectors. So I'm just going to do a quick little summary of something that I know a lot of students have trouble with. And that summary is with the idea of the angle of the vector. So again, we have a vector, right? And we can give that vector a name. In this case, I'm calling it M. And that vector has an initial point and a terminal point. So we got to make sure we have an initial and terminal point. Now, in addition to this vector, it has what we call a magnitude, and that is going to be like the length of the vector. So that's what we use here is going to be the magnitude of a vector. And then it also has a direction, right? Because obviously we want to see like, where is this angle pointing, right? Is it up to the right, over to the left? And that's where trig kind of comes into it. So if we look into our standard form here, we can say this angle here is going to be the kind of like the direction here of this vector. Now, the important thing is a lot of times vectors, we're talking about the initial point, the terminal point, the magnitude. Like we're not dealing with trigonometry a lot. But one thing that's kind of important that we can do is if we want to represent a vector in terms of its angle, we can use the magnitude, which is the length. Let's kind of do this here. And then multiply it by what we call a unit vector based on the angle, which would be cosine of theta, sine of theta. So if we know the angle of the vector as well as its magnitude, we can write that vector based on its magnitude and its angle, which would be a form of vector, which we could convert to component form, which would be useful for many other operations in vectors. So obviously I have a ton of videos on vectors and trig, but hopefully this is just a little bit of an idea introduction for you. But yeah, hopefully this was helpful for you. But yeah, if you have any more specific questions, let me know. SAT exam. I think I was just going to address this because the person was nice enough to ask me. I'm just like, hey, what could I do for the SAT exam? And unfortunately, that is not something I focus much on my channel. I do have some videos for SAT practice and ACT practice where I just kind of went through doing some examples for you. I wouldn't say it's a complete preparation though course or videos for you. I would just highly recommend at this point looking at the companies that are making the money off of people taking the SAT and ACT exams and invest a little bit in them because that's what those are designed to is, help you do really well on those exams. And I don't really fully agree with all of it. I don't think those tests are basically going to be the best way for students to be assessed. But that is our current model at the moment. And so, yeah, those companies are providing resources that, or, even YouTubers. I mean, I would say anybody that's had success and understands and can give you some tips and tricks, I would just go through them. But I mean, I think the main advice I can give is just like anything, practice, prepare, and try to get all that done ahead of time. So therefore, the couple days heading up to the test, you are relaxed as much as possible, because tests can be stressful for many students. And that's why a lot of students, feel that they do poorly on tests, which they may do. But a lot of times they have stress. They have a lot of anxiety, coming to tests. And I think the best way to counteract that is to do as much practice preparation as you possibly can. So when hey, I'm walking into this test, I'm going to do the best I can, and I've studied, I've prepared for this as best I can. It's not the end of the world. Here it goes. And I think that is when you are going to perform your best, when you have released a lot of the pressure off of yourself because you did the work ahead of time. But for those students that, and I was the student that wait till the very, very end, are constantly cramming, trying to do much at the end, you're not going to perform as well. And that's just I think a fact. All right, Kiki brought in a couple questions for inequalities. She actually gave me like a worksheet, I think, that she was doing. So let's kind of go through these problems here. I've already done 8 questions, so I'm going to break out the calculator just to make sure I'm not making some mental math here. But again, just with whenever you're solving inequalities, again, one of the trick I remember when I was learning, just replace the inequality with an equal sign, right? I mean, again, their idea to solve an inequality is to isolate the variable. And we're going to isolate the variable using what we call our inverse operations, reverse order of operations, and properties of equality. So the inverse operations means whatever is being applied to the variable, we're going to undo. The reverse order of operations means that we're going to undo addition and subtraction before we're going to undo multiplication and division. Kind of like if you think about the order of operations, we're going to go in the reverse, right? So think of PEMDAS in the reverse order, and that works for parentheses and exponents as well. And then the properties of equality basically states whatever we do on one side, we're going to do to the other side. So in this case, first thing I'm going to do is undo subtracting or adding an 8 to both sides. And therefore, that's going to leave me with a negative 6, 7 is greater than or equal to a 84. Okay, now there's a couple different ways we could look at this. You could look at this as negative 6x divided by 7. Or you can also look at this as a negative 6/7 x is greater than or equal to 84. Okay, so it doesn't matter if you think of this as one operation or of two, right? X is being multiplied by negative 6 and x is being divided by 7, or x is being multiplied by the fraction negative 6/7. Doesn't really matter. This is going to be one less operation, so that's why I prefer to write it that way. So what that means is if I have something multiplied by a fraction, to undo that, I'm going to divide, right? But again, dividing by a fraction is the same thing as multiplying by its reciprocal. So I'm really just going to multiply by a negative 7/6. Oops, do not do that. It's only one negative. And I'm going to do that to both sides. A negative 7/6. Obviously, anything being multiplied by its reciprocal is going to be go to 1. So then we'll just have x. And again, when we multiply or divide by negative on both sides, that is going to flip the inequality symbol. And then I just have a 84 times a negative 7 divided by 6. And that's going to be a negative 98. Okay, and again, that explanation, I would just recommend working through a more basic problem. You can kind of see how that reason why that flips. I'm just going to be kind of quick with it just because I have more problems to do. And I think that's something, as long as you understand the basics of the process I do, you can easily understand why you have to flip that symbol with a simpler or a more simple problem. All right, and then the last thing I want to do is recommend to graph, right? Because there's multiple numbers. There's actually infinite many numbers that are less than or equal to negative 98. So I'm going to say, all right, on a number line, here's negative 98. It's less than or equal to, so that's going to be part of the solution. And then all numbers less than negative 98, let's say like that's negative 100, are going to be going to the left. All right. Oh, I forgot to turn on my other side light. See how that now makes all the difference. Here we go. All right, so now let's go to the next one. The next one has a lot of negatives. I think that's what the student asked for, was like they didn't like the negatives. Because negatives, yeah, they do they can make things difficult. But again, I would just recommend we want to solve for our variable, get the variable to the same side. Or I'm sorry, undo everything that's being applied to the variable. So in this case, I'm going to add a 14 to both sides. That is going to be a negative 20, I think 24. Right, so that'd be 38. Good is going to be less than a negative 2e. Now I'll divide by negative 2e because my variable e is being divided by negative or multiplied by negative 2. So to undo multiply by negative 2, we're going to divide by negative 2. A negative divided by negative is a positive. 12 is now going to be greater than e, right? We flip the sign. And then again, a lot of people don't like graphing 12 is greater than e. So again, just flip it over. E is less than 12, right? Those are the exact same things. Just read it from left to right or read it from right to left. Okay, so now we can just graph this. We can say, all right, let's do another number line. Let's make 12 here. All numbers less than e, so let's maybe say that's 0. And again, that's going to be, that's less than, so that is not going to be included. So that's going to be an open circle, and it's going to be all values to the left. Okay, so hopefully that gives you a good jump start into solving the rest of your inequalities. And then last but not least, Emily brought in a tangent line problem from calculus. Write the equation of the tangent line given the function f of x equals x times parentheses 1 minus 2x quantity squared or quantity cubed at the point 1 comma negative 1. And just so I didn't forget the product rule, I wrote it down because Emily was not getting the right answer. Her answer was something else. I can't remember. But anyways, I know it wasn't the same slope, and the correct answer was negative 7. So when I look at this function, we're looking at the tangent line. Immediately, tangent line should just scream to you, oh, come on, Legible. I thought I had my things. We don't need to spam, ladies and gentlemen. There's many of us that are in here. We don't need all that. Okay. Yeah, sorry, I wasn't paying attention, and my wife was not on, so I thought she would. She catches you guys. So, but yeah, guys, I mean, I'm always here. I'm here to answer your questions, but I will address the questions at the end, but please don't spam because then that's just going to get you kicked out, and that bothers everybody, and we don't want to bother everybody. All right, and this is my last math question I have for you guys, and then I will get on to the questions in the chat for those of you that are so cool to hang out with me. All right, so whenever I hit tangent line, I immediately just think derivative. So without even like going further, I'm just going to say, let's find the derivative. And I recognize this is a function times another function, right? Now this function is a chain rule, so we do have to write down or remember the chain rule, but hopefully I didn't write it down, but I have it kind of memorized, so I'm just going to kind of go from there. But again, just the idea of remembering that you have two functions here, product. So therefore, we're going to use the product rule of differentiation. So to do f prime, all right, so if I had f of x, let's just call this fx. Well, it doesn't really want to use fxgx, but that's going to be like first function, second function, right? So we're going to take the first function, and then we're going to multiply that by the derivative of the second function. So the derivative of the second function is going to be, let's say 3 times 1 minus 2x. This is going to be the power rule. That's going to be 2. And then this is going to be the chain rule here, because now you have to multiply that by the derivative of the inside of the function, which would just be a negative 2. And then that is that. And then I'm going to add that to the derivative, or to that function here, 1 minus 2x cubed, and then times the derivative of the second function, which is just 1. Okay, now you can simplify this if you want to, and that's perfectly fine. But again, we want to find the value of this derivative function at the point 1 comma negative 1. Well, again, forget about the 1 comma negative 1. That'll be useful later. We want to know what is the slope when x at 1. So what we're going to do is I'm going to say, what is f prime of 1? So if I plug in 1 in for x, quantity squared times negative 2 plus 1 minus 2 times times 1 cubed times 1. Okay, so now let's go ahead and just do a little fun mental math. Oh, that's quantity squared 1. Jeez, wrong parenthesis. All right, anyways, 2 times 1 is going to be 2. 1 minus 1 is negative 1. Negative 1 squared is 1. 1 times 3 is, I'm sorry. Yeah, negative 1 squared is 1. 1 times 3 is 3. 3 times 1 is 3. 3 times negative 2 is a negative 6. And then we're going to add that to this here. So let's see. 1 times negative 2 is negative 2. 1 minus 2, or 1, or sorry, 1 times 2 is 2. 1 minus 2 is negative 1. Negative 1 cubed is negative 1. Negative 1 times 1 is negative 1. So that's going to be plus negative 1. Okay, so the important thing is f prime of 1 is going to be the slope at that point, right? And the answer, which is negative 7, you can see that is the slope, right? And that was the only question that, or the only answer that she gave me that had the slope of negative 7. There was one that had a positive 7, and then I think Emily's answer choice was something else like 2 or something like that. So that'd just be the process. Obviously, you can now use the point slope form, again, to actually write the equation of the line. So now you would use, now that you have the slope, now you'd use the point, actually kind of crazy, just like how that previous question was asked. So now you'd use the exact same equation to go through it, but since that was the only answer that had a negative 7 for the slope, we know that was the right answer. And she told me what the right answer was. So, wow, that was a extra long live stream to get back into everything. But I wanted to check back in with you guys. So thank you so much. Well, let's do some math, guys. Yes, you're right. Z, you're very welcome. Game on Base, you're very welcome. Amanda, absolutely. Fakey Flip, thank you, sir. Haha, same. Hamza Mohammed, I want to thank you for your videos, teaching me math since grade 9. Awesome. Love you. That is so good. Lou, you're very, very welcome for you guys. And if you guys have any other questions, I mean, I guess I'll stay on for a couple more minutes, see how you guys are doing. I do appreciate you guys staying in here with me. Be patient. Yeah, I know. Jeez. Ban him now. Wow. I didn't know. Legit boy. He was going pretty hard. Pre-calculus is more complicated. Yeah, I mean, I would definitely say if you can get through pre-calculus, then calculus is, because the thing about pre-calculus and calculus is the algebra. And even algebra 2. It's the same exact thing. Like, the difficult thing that students have with calculus is the algebra. The difficult thing that students have in pre-calculus is the algebra. And that's why I'm not a big proponent of, all students having to take algebra to graduate, or that all students have to take algebra to go into certain classes. Like, algebra is difficult, and we can game students to game the system. Like, we can make them learn algebra or pass the class or, memorize things. But like, what is that serving them for life, right? Obviously, we want people that are going to a mathematical background to understand those rules of algebra and to have a good foundation. And I'm not saying those rules are not important for everybody, but I don't think it needs to be a gatekeeper for people to advance in their schooling. I think that is something that mathematics is not something that, is time deficient. Like, that meaning, like, you have to be in this grade, you have to pass this class. Like, so many people that are on my channel that watch my videos are, grown human beings. They're adults, right? And they didn't make sense to them when they were younger, but they're going back to school for whatever reason. And they kind of have more of a love for mathematics. And I don't want to take credit for the teaching, but it's because of they now have a different perspective of looking at the mathematics, and they actually enjoy it. And they're like, wow, I just, everything was going on when they were younger and they just didn't really understand things. And now things are clicking and they enjoy it. And I think that's the important thing that we as teachers need to understand is, or not as teachers, but really as like educators in education, that, it's not a race. We don't need people to be racing to understand, this mathematics. We want people to understand this stuff, and we want people to be curious and to enjoy things. So those are definitely some of my points on there. All right, so let's get into, all right, I'll be able to divide a line segment into a given ratio and finding the coordinates. I am not sure. I'd have to think a little bit more on that. My brain kind of feels a little bit like mush. You to divide a line segment into a given ratio and then finding the coordinates. I guess you probably, could. I guess I'd have to kind of see what the problem is. Do you think math classes should teach math history? Yes and no. I think it's important for teachers to kind of, always imply, to let students know about some of those things. And obviously for, becoming a teacher and understanding some of the side, I think it's really interesting. Like, there's a couple books that I read, that literally just blew me out. I was like, wow, this is so cool. I never knew this stuff about math. It really made me more interested in mathematics. So I don't think it should be necessarily a requirement, but I do think it is important for students to kind of know, where things kind of came from and really, yeah, like the foundation of why, because I think if you understand why we taught math or why math was important in our history, you would understand why it's kind of important nowadays. And I think we've lost a little bit of that. And that's why a lot of students are frustrated with it because it's just, it's why are we learning this stuff? So I think maybe looking back might be an easier way than looking forward as far as why we do that. Legit boy, you're back. No worries. But now you know. IMAC, do you have an integrated mathematics playlist on your channel? No, I should. Basically integrated mathematics. If you're looking for one course or another, I have everything from Algebra 1 up to Calculus. So, but yeah, I when I was in high school, I went through a integrated mathematics course. But since that's not something that I currently teach from, it's kind of a little more difficult for me to have things organized. But that's not a bad idea to kind of think about some things like that. So that might be something I might have in the future for you. But I don't think I'm going to have time this year. So I apologize for that. Hi, Professor McLogan. Thank you for all your help through your math career. Your videos have been incredibly helpful. From Kareem. Well, thank you very much, Kareem. That is very awesome. I hope you are doing great. And I hope you're doing great with your courses from that. Thank you so much. Find the equation of the tangent line. 12 of x sine x. Oh, can you divide a line segment into give a ratio and then find the coordinates? Yes, you can. I thought you were just asking in general or a specific question. I would have to just kind of look at that in a little isolated problem from there. And Amanda's asking me to find the derivative of that. Excuse me. Find the equation of the tangent line. Well, that's just going to be the derivative. So yeah, just go ahead and find find the derivative, and that is your coordinate point. Well, again, just go ahead and find the derivative of 12x sine of x, which again, just going to be another power rule for you. And again, you're just going to do the same thing. Find y prime for that function. I don't have time to kind of go through it. But go ahead and find the derivative, and then just plug in pi halves. Actually, let's see. I don't like doing all of my, I don't like going through and doing the trig, but let's go ahead and let's go through this. Functions. All right, so I was just checking that thing. Yep, agreed. All right. Oh, wow, geez. Well, thank you so much, Abdullah. Thank you very much for that. Oh, which divides the ratio into 2/5. Okay. So it's kind of what you're going to want to do. I'm not going to go through this problem because, yeah, guys, I'm just going to have to stop this out. So I'll finish this off. But so it's comical. I'm leaving that thing. What you're going to want to do is take your ratio 2/5. So find the distance between A and B using the distance formula. And then once you find that distance, then multiply it by the ratio 2/5. And then, well, I guess that's one way. It might not be the easiest way. I'd have to think about that a little bit better to give you more efficient. But then at least from there, then you can go from the point A, you can go that distance and add those between those two. That might be the best. I'd have to link. There's definitely an easier way to do that. No, yeah, no, take that back. Don't do that. Because that would only work if you had a horizontal or vertical. You're not going to want to follow that from there. That's a good question. I'd have to actually look at that. It's not something I've done for a while, so I'd have to sit back and think about that. So I am now going to, base 60, physics and calc. Yeah, I'd have to think a little bit more about that. And after doing this live stream, my brain's just not up to par. So I do apologize for that. I will take back my comments. And Amanda, same thing. follow the same process I did, use the derivative product rule, find the derivative, and then plug in pi halves, and then use the point slope form from there. So you're facing some problem. I think math, Adam, I'm just going to kind of give it, I wouldn't say math became easier. I think it really started to make sense once I got through calculus. Once I got through calculus, I just understood things a little bit more. Like things started to connect a lot more for me. So then it just became a little more interesting in learning. And then I kind of saw how a lot of the stuff that I learned before really kind of made sense. So I think really that is when things started to connect and maybe make it a little bit easier. I started to see how the rules and everything were related. So all right, guys, I am done. Thank you so much for joining. I'll be doing another training tomorrow night for those of you that are taking pre-calculus. So make sure to join. It is going to be a premiere video. So I'll be joining in the chat, checking in with you guys and going through that. So super excited for that. Feel free to go through PC Foundations to download the workbook and go ahead and get started before that training. But otherwise, guys, for tonight, I am signing off and I will see you guys next week. Be sure if you guys do have more questions you'd like me to answer, go to the Google form and submit it there, or go to the Discord community that is also in the chat. And I might be able to feature your question next week. All right, guys, have a good evening. I'll see you guys